Now let's talk about combinations. In our previous video, we talked about the permutations. As you can see on this picture, we said that if I have three hobbies, playing tennis, playing basketball, and cycling, and I want to play two games, we saw that we can arrange these two games in six possible permutations because the order in which I play my games matter. Starting by going to cycling and then going to playing basketball, or starting by playing basketball and going to cycling. These two cases were different. Two choices were different. But what if the order in which I'm playing my games doesn't matter? What matter is playing two games. So in that case, this case and this case will be the same because I am playing basketball and cycling, regardless of the order I am doing those games. Again, this case and this case will be the same because I'm playing tennis and playing basketball. I don't care about the order in which I'm playing those games. So this case and this case will be the same. Again, if I don't care about the order in which I'm playing my games, playing tennis and then going to cycling will be the same as starting by going to cycling and then play tennis. What I care about is that I do those two without considering the order I am doing my games. So you can see that if the order matters, I will have six possible permutations, six possible arrangements. But if the order doesn't matter, so I will, for instance, if I, if for instance, for instance, I I have to ignore these once I have taken this one because these are the same because the order doesn't matter. Again, I have to ignore this one if I take this one. Again, I have to ignore this one if I take this one because they are the same. So if the order doesn't matter, arranging objects when the order doesn't matter, that's what we call combinations. We saw that the formula for computing permutations when the order matters is this one here. Yes. But now, what about how do we compute these possible arrangements when the order doesn't matter? How do we compute the number of combinations that we may have? Let me write it down. The formula that we use, it's a different formula. Yeah. It's a different formula. I write it down here. This is combination. And let me first write again the permutation formula. The permutation formula, we saw that it's a PNR, which is equal to n factorial over n minus r factorial. This was permutation. But then to take care of removing similarities, taking care of removing this one and removing this one and removing this one and keep only one case for similar cases. So we change our formula into this formula. Let's say the combination n r, and the formula is n factorial over n minus r factorial and times r factorial. This is our new formula for the combination case. when the order doesn't matter. Yeah, in our case, let's try to compute these to compute these combinations, because in our case n was equal to 3 and r is equal to 2. So then combination 2 3 will be equal to 3 factorial over 3 minus 2 and factorial times 2 factorial, which is equal to 3 times 2 times 1 over 1 factorial. This is 1 times 2 and times 1, of course. Then this and this and this, and 3 over 1 is equal to 3. So we only have these 3 cases as we have seen up here. We only have these 3 cases, this and this case, and this case. So that's the difference between permutation and combinations. For permutations, the order matter a lot. But for combinations, we don't care about the orders. No order when we are arranging our elements, our items, our objects. So that was it, and that's it. Thank you.